So difference between y1 minus y0. So delta y1 is equals to y2 minus y1. Similarly, y3 minus y2, y3, y4 minus y3. So that is, these are the differences. 1 minus 0 is 1, 8 minus 1 is equals to 7, 27 minus 8 is equals to 19, 64 minus 27 is equals to 37. So next also, second order, delta square y is equals to 7 minus 1, 6, 19 minus 7 is equals to 12, and 37 minus 19 is equals to 18. So next, third order derivative. Third order, 12 minus 6, 6, 18 minus 12, 6. Next, fourth order, 6 minus 6 is equals to 0. So this is the forward difference table. So this is total forward difference table, construction of forward difference table. He is asking only delta square y0 and delta square y0, comma, delta square y1 and delta y2. So delta y2 is nothing but, so y0, y1, y2. So this is delta y2. So this is y0, y1, y2. So 19 is nothing but delta y2. So last one answer, delta y2. So next, delta square y0, delta square y1 is nothing but, next, second order. So this is second order. In second order, so this is y0, y1, y2. So delta square y0 is nothing but 6. And delta square y1 is equals to 12. So this one. So delta square y0 is equals to 6. Delta square y1 is equals to 12. Delta square delta y2 is equals to 19. These are the three values. 19, 6, 12. Okay. So this is delta y0, delta square y0, delta square y1. So this is forward table. Construction of forward difference table. Next, backward difference table. Backward difference operator. This is nabla, reverse. So nabla is equals to yt minus yt minus 1. Yt minus yt minus 1. So in forward difference table, here, in forward difference table, so we are fixing y0. So y0, delta y0, y0, delta y0, delta square y0, and delta cube y0. So here fixing y0 and here also y0. So reducing, so decreasing y4 to y3, y3 to y2, y2 to y1, and y1 to y0. You know, so decreasing last number 4 to 3, 3 to 2, 2 to 1, 1 to 0. So that is nothing but here y0 is fixing starting term to last term. Y0 is fixing. So but here in backward operator, backward difference operator, so this is indicated by nabla. So this is backward difference operator. So formula is nothing but y1 is equals yt is equals to yt minus yt minus 1. So table is same. The table x0, x1, x2, x3, y0, y1, y2, y3. So delta y, delta square y, delta cube y. So but table is same. Difference between two. So delta y1 is equals to y1 minus y0. So table is same total. So but here in forward difference operator, we are fixing y0. We are fixing y0. So but here in backward difference operator, we are fixing y3. So y3 is fixed here, delta y3 remaining, delta y2, delta y1, nabla y1. So next, nabla square y3, nabla square y2. Next, nabla cube y3. So here we are fixing y3 is nothing but highest term of y, highest term of y. We are fixing highest term of y. You know? In backward operator, the table total same. Y2 minus Y1, the difference between these two, the difference between these two, delta Y1, the difference between these two, this one, the difference between these two. So, but we are fixing last highest term of Y, that is Y3, 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 Y3 in backward difference operator. In forward difference operator, we are fixing Y naught, delta Y naught, delta square Y naught, delta cube Y naught. But here Y3, delta Y, nabla Y3, nabla square Y3, nabla cube Y3. Okay. So we are fixing last last element in backward operator, backward difference operator. In forward difference operator, we are fixing Y naught. So these are the forward and backward. Interpolation and extrapolation. So this is in this first method, Newton's forward interpolation formula. So Newton's forward interpolation formula. So Newton's forward interpolation formula. So P of x is equals to P of x naught plus h into u. P of x naught plus h into u, that is equals to, so formula this is y naught. First term is y naught plus u into delta y naught. So Newton's forward difference formula. Newton's forward difference formula, y naught plus u into delta y naught, u minus u into u minus 1 by 2 factorial into delta square y naught plus u into u minus 1, u minus 2 by 3 factorial into delta cube y naught up to so on, u into u minus 1 up to so on, u minus n plus 1 divided by n factorial into delta power n y naught. So this can be written as y naught plus uc1 delta y1 plus uc2 delta y2 plus up to ucn delta yn. So this is simple formula, y naught plus uc1 delta y1 plus uc2 delta y2 delta square y2 up to so on u cn delta power n by n. So this is combination. UC1 is nothing but u into delta y1. UC2 is nothing but u into u minus 1 by 2 factorial. U into u minus 1 by 2 factorial into delta square by 2. Is clear? So this is the formula for Newton's interpolation formula. Y naught plus u into delta y naught plus u into u minus 1 by 2 factorial into delta square y naught plus u into u minus 1, u minus 2 by 3 factorial into delta cube y naught. So next, Newton's backward difference formula. So this is Newton's backward difference formula, yn. So in forward difference formula, y naught, starting term. In backward difference formula, yn, y last term. Yn plus u into delta yn plus u into u plus 1 by 2 factorial. Nabla square yn up to so on. U into u plus 1, u plus 2 up to u plus n minus 1 by n factorial into nabla power n into pi n. Okay. So this is backward difference formula. Newton's backward difference formula, Newton's forward difference formula. So these are the two important methods for exam. examples. The population of a town. So population of a town in years and population in lakhs. So 1941, 1951, 1961, 1971, 1981, 1991. So in lakhs 20, 24, 29, 36, 46, 51. So use Newton's forward interpolation formula for estimating the population in 1975, 1975 and find the increase in population during the period of 1975 to 1981. Is clear? He is asking Newton's backward interpolation formula. In case he cannot mention backward or forward. So middle of the table. Here middle of the table is nothing but, so this is middle of the table 61, 71. So we have to find out 1975. So 1975 and here. So we can choose backward. In case he is asking 1945. So 1945 is nothing but we can use Newton's forward formula. So front side is nothing but Newton's forward formula. So this side is nothing but Newton's backward formula. You know? So here 1975 is nothing but we are using Newton's backward formula. But he is given using Newton's backward interpolation formula. You know? X naught. X naught is nothing but starting term. So this is X, these are Y values. X naught, X1, X2, X3, X4. So like Y naught, Y1, Y2, Y3, Y4. So years is nothing but X values. X naught, X1, X2, X3, X4. And population Y naught, Y1, Y2, Y3, Y4. So these are the X and Y values. So Xn is not X naught is nothing but Xn is nothing but 1991, last term. Xn 1991 and Yn also 51. So this is Newton's backward formula. We are using Yn is nothing but 51, Xn is nothing but 1991. So these are the values. Xn 1991, X is nothing but 1975 is given. It estimate the population in the year of 1975. So that is X value. H is nothing but length of the interval. So difference between uh, 1941 1951 minus 1941. The difference between each and every interval. So 10. So that is H value. H is equals to 10. And we have to calculate U value. So U is equals to formula X minus Xn by H. U is equals to formula X minus Xn by H. So this is the formula for U. U is equals to X minus Xn by H. X is equals to 1975. In which year we have to calculate total population. And Xn is nothing but 1991, last term. And H is nothing but length of the interval. The difference between each and every interval is 10. So that is H. X minus Xn by H. So that is formula 1975 minus 1991 by H. So that is U is equals to minus 1.6. U is equals to minus 1.6. So this is a U value. Next, table. Difference table. So difference table. So X values and Y values. X values is nothing but years. 1941 to up to 1991. So next, Y is nothing but population in lakhs. 20, 24, 29, 36, 46, 51. So next, we have to find out nabla values. Nabla Y. So nabla Y is equals to difference between these two. 24 minus 24. Here also 29 minus 24, 5. 36 minus 29, 7. Here 51 minus 40, 46 minus 36, 10. Fifth one minus 46, 5. Similarly, here also delta square y, delta cube y, delta power 4 up to delta power 5, up to single term. So forward difference is nothing but we can take so these values. So backward is nothing but we can take these values. So this is forward difference y naught, y naught, delta square y naught, delta cube y naught, delta power 4 y naught. So backward is nothing but ym, delta square ym, delta cube ym, delta power 4 ym. So these are the backward formula. So these are the backward values. These are the forward values. Next formula. Newton's backward interpolation formula. Actual formula yn plus nu into delta yn plus u into u plus 1 by 2 factorial into delta square yn plus u into u plus 1 into u minus 1 by 3 factorial into delta cube yn. So but here yn is nothing but 1991. Here replace yn 1991. Write down up to formula delta power 4 and up to fifth order. So we know u value. U is equals to minus 1.6 and delta y 1991 is nothing but starting value. So this one. So this is delta 1991. So this is delta square 1991. So these are the delta cube 1991, delta power 4 1991. So these are the yn values. So substitute yn is nothing but 51 1.16 minus into 5. So substitute all values. So we are getting after simplification 39.79022. So the population in 1975 is 39.79022 lakhs. Increasing in population during the 1975 to 1981. So 1981 population is 46. 1981 population 86 minus 1975. So 1975 39.79022. So this is increasing population in these 1975 to 1981. So 6 lakhs 6.2978 lakhs. So this is the increasing population. Next example. Given x, y is equals to tan x 35, 37, 39, 41, 43, 45. So y is equals to tan x 0.70021 to 0.75, 0.85, 0.86, 0.93, 0.1. Use Newton's interpolation formula to obtain y40 and y47, y49 and y51. We have to find out these values also. y40, y47, y49, y45. The table x, y values x0, x1, x2, x3, x4, xy is given table. So 35, 37, 39, 41, 43. So these are the x values. So y is equals tan x is nothing but 5 values in table. So delta y is equals to same table. So difference between these two. So we can construct forward difference table. Okay, na? So this is the delta y. So next delta square y is equals to difference between these two. So we can construct delta cube y, delta power 4y, delta power 5y. In forward difference table or backward difference table is same. So but formula is different. In forward or backward, table construction is same. So but formula is different. In forward difference table, we can take y naught values. In backward difference table, in backward difference formula, so we can take yn values like yn, delta yn, delta square yn, delta cube yn, delta power 4 yn, delta power 5 yn. So in forward, y naught, delta square y naught, delta cube y naught, delta power 5 y naught, delta power 6 y naught. The next is asking y40. So y40 exactly middle. Y40 exactly middle. So we can take Newton's forward or backward formula. So we are taking Newton's forward difference formula. U is equals to x minus x naught by h. U is equals to x minus x naught by h. X is equals to 40 is given. Find y40. So x is equals to 40. So x naught is 39 starting. H is equals to 2. That is 1 by 2. So y40 is equals to y naught plus u into delta y naught plus formula, Newton's forward difference formula. So this one. So formula y naught plus u into delta y naught plus u into u minus 1 by 2 factorial delta square y naught, u into u minus 1 into u minus 2 by 3 factorial into delta cube y naught. So this is the using this formula. So this is y naught plus 1 by 2 into delta y naught plus u into u minus 1 by 2 factorial into delta square y naught plus u into u minus 1 u minus 2 by 3 factorial into delta square y naught plus u into u minus 1 u minus 2 u minus 3 by 4 factorial is nothing but 24 into delta power 4 y naught plus u into u minus 1 u minus 2 u minus 3 by 5 factorial 120 into delta power 5 y naught. Simplify. So we are getting y40 is equals to 0.83910. So this is the y40, that is tan 40. Next, central difference formula. First one, Gauss central difference formula. So this is the formula. Y is equals to y naught plus u into delta y naught plus u into u minus 1 by 2 factorial into delta square y minus 1. Here, delta square y minus 1 plus u into u square minus 1 delta cube y minus 1 by 3 factorial plus u into u minus 1 u minus 2 delta power 4 y minus 2 by 4 factorial plus u into u square minus 1 u square minus 2 square into delta power 5 y minus 2 by 5 factorial. So this is Gauss forward central difference formula. The table 0, -1, -2, -3. 1, 2, 3. So this is y naught, y minus 1, y minus 2, y minus 3. So u values corresponding y values. Y minus 3, y minus 2, y minus 1, y naught, y1, y2, y3. So next, here in central difference formula, we are fixing starting value. So that is y minus 3. So decreasing. We are fixing starting value decreasing. So y minus 3 is fixed. Delta y minus 3, delta square y minus 3, delta cube y minus 3, delta power 4 y minus 3. So remaining are decreasing. So delta y minus 2, delta y minus 1, delta y minus y naught, delta y1, delta y2. So here 1 is decreasing. Y3 to y2. So next, y2 to y1, y1 to y naught, y naught to y minus 1, y minus 1 to y2. So here fixing starting value in Gauss central forward difference formula. The table is same. The difference between these two, delta y minus 1. The difference between these two, delta y minus 2. The difference between these two, delta y minus 2. So table is totally same. Newton's forward, Newton's backward, or Gauss forward, Gauss backward. In each and every case, the table difference values is same. Y2 minus y1. The Gauss backward formula. So this is backward formula. Y is equals to y naught, u into delta y minus 1 plus u into u plus 1 delta square y minus 1 by 2 factorial plus u into u square minus 1 by delta cube y minus 2 by 3 factorial plus u into u square minus 1 into u plus 1 delta power 4 y minus 2 by 4 factorial plus u into u square minus 1 u square minus 2 square into delta cube y minus 3 by 5 factorial. So this Gauss backward central difference formula. So this is Gauss backward central difference formula. Example. Use Gauss forward formula to find the value of x is equals to 3.75. X is equals to 3.75. Given data is given x and u values. So 2.5, 3, 3.5, 4, 4.5, 5. Corresponding u values 24.145. So these are the corresponding values. So in this table, we have to find out 3.75. So 3.75 is near to 3.5. 3.75 is near to 3.5 and 4 also. So, but we are consider 3.5. We are consider 3.5. So that is x naught comma y naught. So this is x naught comma y naught. So previous values x1, x minus 1, x minus 2. So this is x1, x2, x3. U minus 1, u minus 2. So this is u naught, u1, u2, u3. Is clear? So here consider 3.5 is x naught because x is equals to 3.75. We have to find out x at x is equals to 3.75. So which is nearly equals to 4 and 3.5. So but we are consider only 3.5. So that is x naught. So previous values are -1, -2. Next. So these values are 1, 2, 3. So take 3.5 at origin and h is equal to 0.5. H is nothing but difference between these. these values 2.3 minus 2.5, 0.5, 3.5 minus 3, 0.5, 4.5 minus 4 minus 3.5. So length of the interval is h. H is equals to 0.5. So define the new variable. So t is equals to x minus x naught by h, Newton's forward. T is equals to x minus x naught by h. So that is t is equals to 0.5. So this is Newton's forward formula. T is equals to x minus x naught by h. X is equals to 3.75 minus x naught is 3.5 divided by length of the interval 0.5. So that is 0.5 is t. Next, table construction. T u. So t values, u values is given. Delta u. The difference between these two. The difference between these two. Table is same. The difference between these two values. So this is the table, and so this is delta. So this is x naught. This is x, y, u minus 1, u minus 2. So this is delta u2. This is delta u1. This is delta u. Delta u1, delta u2. So this is delta square u minus 2. Delta square u minus 1. So clearly we are fixing minus 2. We are fixing minus 2. Starting term. We are fixing minus 2. That is delta u2. Delta u minus 2, delta square u minus 2, delta cube u minus 2, delta power 4 u minus 2, delta power 5 u minus 2. So remaining values are decreasing. Gauss forward formula. So u naught plus t into delta u naught plus t into t minus 1 by 2, 2 factorial, delta square u minus 1 plus t plus 1 into t minus 1 by 6 into delta cube u minus 1 plus t plus 1 t into t minus 1 t minus 2 by 24 into delta power 4 into u minus 2. So we know t value, t is equals to 0.5. In this formula, t is equals to 0.5. Okay, t is equals to 0.5. U naught is equals to 35. U naught is nothing but 20.225. So this is u naught value, 20.225. So delta square u minus 1. So this is delta square u minus 2. So this is delta square u minus 1. So this value delta delta square u minus 1. So next, so this value delta q minus 1. So this is delta q u minus 2, delta cube u minus 1. This one. So next, delta power u minus 4, delta power u minus 2. So next, delta power 5 u minus 2. So these are the values. So substitute these values. So we are getting 19 point, after simplification, 19.4074. So this is Gauss forward formula. Similarly, Gauss backward also. Use Gauss formula to interpolate for the population 1976. Given data is given year sign population in lakhs 1941 to 1991 and population in lakhs 12, 15, 20, 27, 39, 52. Same here also, x is equals to x minus x naught by h. X is equals to x minus x naught by h. So here we are taking x naught. X naught is equals to middle term. 1976. So 1976 is near to 1971. So 71, 76. So that's why we are taking 71 is X naught. So this is X naught. X naught corresponding U naught. X naught corresponding Y naught or U naught. So these are Y minus 1, Y minus 2, Y minus 3. So this is Y1, Y2. So this is Y naught. X is equals to X minus X naught by H. So Gauss forward formula, Y is equals to Y naught formula. So this is Gauss forward formula. Y naught plus U into Y minus 1 plus U into U plus 1 delta square Y minus 1 by 2 factorial plus U into U square minus 1 delta cube Y minus 2 by 3 factorial plus U into U square minus 1 U plus 2 delta square Y minus 2 by 4 factorial plus U into U square minus 1 U square minus 2 square into delta cube Y minus 3 by 5 factorial. Gauss for backward formula. So this is backward formula. The next difference table. The difference table. So 0, minus 1, minus 2, minus 3, 1, 2. So these are the X values. So Y values 27. So this is X naught, Y naught. Difference table is nothing but same. 15 minus 12, 3. 20 minus 15, 5. 27 minus 20, 7. The difference table is same up to last delta power 5. To substitute these values in this formula, so we are getting directly 32.3437 lakhs. So this is example for Gauss backward interpolation formula. So in this first chapter, important topics are Newton's forward, backward, Gauss forward, Gauss backward. So these 4 topics are important. Next chapter 2, we will discuss tomorrow.